Hello everyone and welcome back to my video series on Python fundamentals. I'm George B. Smith. So in this video we are going to be talking about sets. Okay, what are sets? What do we use set for? When do you need this set data structure as opposed to list and then tuples? Now sets are also mutable data type, just like lists, unlike tuples. But the only difference, one of the difference you have between list and then sets is that unlike list that can accept duplicate items, in sets you can accept, it doesn't accept duplicate items. Okay, so even if you have 20 of 7, it's going to take just 7. It will ignore the remaining 19 of the 7s. That's just the basic idea you have in sets. Okay, so whenever you're trying to implement something that you don't want duplicates, you don't any other duplicate should be ignored, then your best bet should be for you to use sets. One good thing is that these data structures, one can be converted to the other. It's quite easy. So without wasting much of your time, let's move down to our IDE and see how this can be worked with. Okay, so let's see. So we are using Jupyter Notebook. How do we create a set? We use the braces to create a set. Right? The braces. So I can say I want to create my set of numbers, or let's say set of even numbers. Should I say even numbers? Yeah, even numbers. So I'm going to create the set of even numbers. So the set of even numbers I have, let's start with 2, 2, 4, 6, 8, 10, 12, let's have up to 14. Now don't mind the fact that I'm ordering this. The items you have in a set, they are not ordered. So set is also one other unordered data type, just like dictionaries. Okay, so I have even numbers. So you can see this is what I have: 2, 4, 6, 8, 12, and then 14. So next, let's have some prime numbers. But we are going to work with these two. So let's have some prime numbers. So for prime numbers, I have 2, 3, 5, 7. Let's have 11, and then let's have 13. These are prime numbers we have. So there are different things I can do with this. Possibly I may want to add new items to this set. Let's take the even numbers for instance. If you want to add new items, you use add. Then you put the numbers you want to add. So I may say, okay, I want to add, I stopped at 14. I want to add 16 to it. So now if I check what even numbers are, I have 16 inclusive in it. Okay, so the same thing goes to prime numbers. I may want to add new items to prime numbers. So let's see for prime numbers, if I want to add new items to prime numbers. Let's just take a peek. Okay, it just added one item. So let's say I stopped at 13. Now I want to add another prime number. I want to add 21 to prime numbers. So if I check what prime numbers are now, I'll get 21, 17 inclusive for the prime numbers. Now, just like all other operations you can perform on sets, all operations you can perform on sets, you can also perform them on sets you have here. Okay, the operations you can perform on sets in mathematics can also be performed there. But before we go into those operations, let me just show you that even if you try to add new items to your sets, it will actually be ignored. So if I try to add 2 to even numbers, I already have 2 there. It's not going to give me an error, but 2 won't be added any longer because I already have 2 there. That's one thing you have to take note of. Okay, so one of the operations I want to perform is to get the intersection between these two sets. If I want to get the intersection between these two sets, I can say what's common to even numbers. There's a method called intersection. What's common to even numbers and then the prime numbers. You can guess it by now that the result is going to be a 2. So we have a singleton, just one item common to even numbers and prime numbers, right? I can also decide to take the union of even numbers and prime numbers. But if I take the union of even numbers and prime numbers, another operation we can use to get the intersection between these two, instead of us using the method intersection, we can simply use this symbol. So we can say even numbers and prime numbers, and it's still going to do the same thing, giving us the result as 2. So now let's get the union. So if I want to get the union, I'll say even numbers dot union. Okay, I want to get the union of even numbers and prime numbers. So this is going to take all numbers in even and odd, put all of them together without repetition, remember. So it's going to pick all the items and put them together. So you can see I have all the even numbers here, 2, 4, 6, 8, 10, 12. I have all the odd numbers, all the prime numbers here. To some extent is arranging it for us, but that shouldn't fool you. We don't have them. Sets are not actually ordered. You can't try to extract the first item or extract the second item. It's not going to work out. Okay, say set object is not subscriptable. That's one thing you have to note. So another way we can get the union without using the method is to use, you can guess it by now, the pipe symbol. So I can use the pipe symbol to get the same result. This is going to give me the union of the two sets. So that's for intersection and for union. Next, we also have what we call set difference. So set difference is simply, hey, I want to extract all items common to these two sets from the first set. Okay, for example, this is what I mean. If you recall, 2 is common to prime numbers and odd numbers. If you want to get the set difference of these two, of even numbers slash prime numbers, it's going to remove 2 and give you just these ones. So remove what's common to both sets, and that's what you call the set difference. So I can say, okay, even numbers dot difference. Okay, we say difference. So difference prime numbers. So it's going to remove 2 from even numbers and then give you your result. So you can see it's removing 2 from even numbers. But if you do it the other way around, prime numbers difference even numbers, is going to remove 2 from prime numbers and then give you the result you have there. So this is going to remove 2 from prime numbers, and then I have 3, 5, 7, 11, and so on. So that's how you get the set difference between two sets. We also have what we call another way you can get the set difference. So using this operation difference, you can just use the subtraction sign. So I can say prime numbers minus even numbers. This is still going to do the same work for me. Prime numbers minus even numbers. Okay. Then we also have the symmetric difference. So for symmetric difference, you're looking at what is in both sets. Take everything in both sets, but don't include what is common to them. So it's going to take the things in A, take the things in even numbers, take everything in odd numbers, but then it's going to ignore 2. That's what you call the set union. Okay, the symmetric difference. So I can say dot symmetric. So the symmetric difference of even numbers and prime numbers is giving me everything in both sets except 2, because 2 is common to both of them, right? So if you've not studied these things in mathematics, set concepts, sets algebra, I think you should go and review them so that you better understand most of the things I'm doing here. So that's why I'm not trying to go that deep into the set concept. Okay, so another way we can achieve this, instead of using the method, we can use this caret symbol. So I can say even numbers, prime numbers, and that's still going to give me the same result. The caret symbol signifies set difference in Python when you're working between two sets. Okay, so the next thing we are going to see is how do we remove items from a particular set. So for you to remove item, you have the pop. But unlike pop in other cases that remove the last item, pop here removes the first item. So if I say even numbers, pop, you can see it's giving me the first item. So if I check what I have in even numbers now, the first item is no longer there. So I can try it again. I say even numbers dot pop. Now it's going to return 4. So if I check what I have in even numbers, 4 is no longer there. Okay, we have other methods here apart from these ones I've just treated. We have clear. Clear is going to wipe everything you have in a list. Difference updates, you should study what that means. In fact, let me give you a hint so that you're going to study other ones. So this is going to I think first I should explain update, or let me explain intersection. Intersection is going to look for intersection between the two sets, but the result is going to be in the first set. Okay, so it's going to replace the first set by the result. It's not creating something new. Then here you use it to check if things are subsets and the rest of that. So these are different concepts. We have a lot of them. We have remove. Remove, you can use it to tell the interpreter the actual item you want to remove there. So I can say I want to remove 12, and automatically it's going to take away 12. So now if I check what even numbers are, 12 is no longer going to be there among even numbers. Okay, so like I said, there are a whole lot of things in sets to treat, but you should go and review them, review the concept, look at other methods I've not treated there, and then if you have any question, go ahead and put them in the comment section below. And as usual guys, I'm going to see you guys in the next video where we are going to be talking about loops. So this is officially the last video we have in this model, okay, set theory. So from the next video we are going to talk about loops. We're going to look at, we'll start with the for loop and then we'll go into the while loop. Okay, so don't forget guys to like and subscribe to my channel, share these videos among your friends if it's helpful in any way, and I'll see you guys in the next video. Bye bye.